Welcome to the third lecture of DSA Complete Course in Python. So, what we are going to study in third lecture is time and space complexity. Time and space complexity plays a major role in deciding the efficiency of our code. Less is the time and space complexity of our algorithm, more is the efficient our code. So let's see what is time and space complexity definition wise. First, let's see what is time complexity. Time complexity measures how the running time of an algorithm grows as the size of input increases. So time complexity is basically what time an algorithm takes to complete. It depends upon size of input. As the size of input increases, time complexity is definitely going to increase. Now let us talk about space complexity. Space complexity measures how much memory an algorithm uses as the size of input increases. Basically, space complexity is also dependent upon size of input. As the size of input increases, the space complexity is necessary to be increased. It will depend upon our code, how efficiently we have written our code. The space complexity and time complexity will vary. So there can be three cases: best case, worst case, and the middle case. Let's discuss the worst case. Suppose we have written a code, it will have highest possible time complexity and space complexity beyond which the code will not run. So this is nothing but the worst case. In the best case, your time complexity and space complexity will be least as possible. And in the middle case, it will lie in between. What is big O? Big O is the language and metric we use to describe the efficiency of algorithms. Different big O notations. First is big O. It is complexity that is going to be less or equal to the worst case. Then big omega. It is a complexity that is going to be at least 1 more than the best case. Then big theta. It is a complexity that is going to be at least more than the best case. Actually, there is a typo over here. Big theta is not at least more than the best case. Actually, it lies between big O and big omega. It is the middle case as we discussed earlier. Different runtime complexities are constant, linear, logarithmic, quadratic, and exponential. So we are going to study all these one by one. So first is oven time complexity. In oven time complexity, number of operations are going to be constant. As you can see in this example, we have created a function add. In this function, we are going to return addition of the given two passed values. As you can see here, I have passed value of a and b as 4 and 4 respectively. So after running it, we will get output as 8. You can see over here. So whatever be the value of a or b, the number of functions that are going to be performed will remain 1, that is constant. So this is our own time complexity or constant time complexity. Now we are going to see own time complexity or linear time complexity. So in linear time complexity, you can see that the time complexity grows proportional to the size of input. So here in this example, I have made a function traverse. In this function, for I in range n, print I. So let's run this line of code. So as you can see, I have passed the value 8 and it has run the function 8 times. That is, value of n was 8 and this function was run for 8 times. Now let me pass the value over here 100 and let us run this function again. You can see that this function has been run for 100 times. It means that the number of times the function will run is equal to the value of n. That is, as our input grows, the number of times the function will perform will definitely grow. So this was O(n) time complexity or linear time complexity. Now let us see the concept of removing constants. So for example, I have taken a random function over here passing value n. So the first line of code for I in range n print I. So this is basically our traverse function and its time complexity will be, let me write O(n). It will have linear, that is O(n) time complexity. Okay. So after for loop, you can see that outside the for loop there is a single print statement, that is print n. So this will also run always. Let me write what will be its time complexity. Its time complexity will be O(1), constant time complexity. How? Because whatever be the value of n, the print statement will always perform one function, that it will be going to print value of n. It will not perform any extra function. So its time complexity is constant. That is, whether the value of n is increased, the time complexity for print of n, this statement will not increase, but it is different in case of for loop. With increase in value of n, the number of operations for this loop will increase, and that's why its time complexity is linear. So what is the overall time complexity of this function? So the overall time complexity of this function will be O times n plus 1. So let's run this function. So as you can see, the function is run for 5 times, that is 4 times for this loop and 1 time for this statement. So changing the parameter value, you can see that as I am giving the value 99, or let us give it 100, and I am running the function again, you can see that the print statement will always run for 1 time, and the number of operations because of for statement will depend upon value of n, that is, it's linear. So let's come back to the topic of removing constant. So our overall complexity from this is O(n) plus 1. So what we do is, whenever we find constant over here, we will neglect it, and our final complexity will become O(n). That is, we will delete the constant value that came over there. So our final time complexity for this operation will become 1 plus 1. After neglecting O(n), we will get it O(n). So let's see another example of removing constant. Let me copy it over here, and let me delete this. Okay, I will write here another loop for j in range n, again print j. This is another for loop, and let me comment out this part so that it doesn't disturb us. Okay, let's clear out this terminal. Okay, let's run this code. Oh, we didn't pass any value, sorry for that. Random, let me pass the value 10. Let's run this code. So as you can see, this code has run for like 20 times, including I and j statement. So what is the time complexity for this line of code, for this loop? It is basically O(n) time complexity, as we have studied earlier. And for this print statement, it is O(n) time complexity, because it is going to print a single statement. And again, for loop, it will be O(n) time complexity as we have learned earlier, and again for print statement it will be O(n) time complexity. So for this particular loop and print statement, the total time complexity will be O(n) and O(n) plus 1, that is O of n plus 1, n plus 1, which will become, on removing constant, O(n). And for this loop and print j statement, time complexity will be again O(n) n plus 1. That will further become O(n) on removing constant. And for the overall function, uh, okay, for the overall function, time complexity will be O(n) plus O(n), which will become O of 2n. So what about this O of 2n? Which type of complexity it is? So again, whenever you see constant with n, either by multiplied or by added, like here, we will remove that constant. So our final time complexity will again become O(n). That is, we have deleted this constant too. So this was our concept of removing constants. Now let's discuss O(n) square time complexity. I have taken here example of one sample function called sample, and I have passed a parameter called n in it for I in range n and for j in range n, print I comma j. So let's run this function. So as you can see that this function has run for 4 times. So as you can see, the value of n we passed is 2 and the function has run for 4 times, that is n square times. So let's see its time complexity. So for I in range n, so for loop will have time complexity O n. Similarly, let me copy this so that it will be easy for me, and I will paste it over here. So these two for loops will have O(n) and O(n) time complexity, and the print function will have O(1) time complexity. So here, as you can see that these are nested loops, the total time complexity of these two nested loops will be equal to O, sorry, total for nested loops will be equal to O(n) square time complexity. This n and n will get multiplied, that is O(n) into n. And for complete function, you can see that total time complexity will be time complexity. I'm sorry, I forgot to comment that. Total time complexity will be O(n) square plus 1, this one, okay, O(n) square plus 1, which will be equal to O(n) square. That is, we have removed this non-dominant constant term 1 as we have studied earlier. So time complexity for this function will be O(n) square. Let's see another example. Uh, let me, okay, I will type it again as sample 2 and n. Then let me copy this so that it will be easy and it will take less time. Okay, for I, j, and this time I'm going to pass a third variable k, and then print I, comma j, comma k. Okay, uh, then so let's run this code. Uh, Let me clear the terminal first, and let's run this code. Uh, you can see in the output that for the value of n equals to 2, our number of operations we get are 8, that is 2 to the power 3. So let's see how. So for first loop, time complexity will be O(n), as we have seen earlier. Then for second loop, it will be O(n) again. For third loop, it will be O(n) again. And for the print statement, it will be O(1), as we have seen earlier. So these three loops, total time complexity will be O times n into n into n. That is, here it will be O times n to power 3, O n cube. And talking about total time complexity of the function, it will be O n cube plus 1, which will be equal to O n cube, because we have removed the non-dominant term, which was constant 1. So O(n) cube is not any special time complexity. It comes under O(n) square time complexity. So whenever it comes O(n) cube, O(n) to power 4, we will count it as O(n) square time complexity. We will take it under that category. So this was all about O(n) square time complexity. Let's understand neglecting of non-dominant terms with one more example. Let me create here a new function called sample3. I will pass n there, and let's just copy these loops. Okay, okay, okay. Let me change the variables as well. I, j, and k. Print I, comma j, comma k. Let's do one thing. Let, okay, I can explain in that way also, but let me explain you with this example first. And for k in range n, print k. Let's clear out our terminal, and let's run out this code, sample3, and let us pass the value 2 again, simple value, to understand. You can see that these are our results. Okay, so let's understand time complexity for this function. So as you can see here, for these two loops of for, our time complexity will be uh, total time complexity O n. I have considered these two loops, and for print statement, it will be again O1, and overall it will be On, because one is non-dominant term. It will become total On for this part of code. Okay, now here, so let's read this. Here for this loop, time complexity will be On, and for print statement it will be again O1, and O1 will be neglected and it will remain finally On. So I have missed one thing in above loop. Here we have two for loops, that's why it will be O n multiplied by n, that is, it will be O n square basically. So for upper part loop, it will be O n square. For this for loop, it will be O n. So what will be the total time complexity for function sample 3? So it will be simple addition. It will be n square plus n. As you can see here, there is no constant term because 2 is in exponential form of n, so it is not constant anymore. But you can see that n square is more dominant than n. So here we are going to neglect n and our final time complexity will become O(n) square. So this is how we are going to deal with neglecting the less dominant terms. In further videos, we are going to practice codes for linked list, arrays, different data structures and different algorithms. There we are going to calculate time complexities in similar way. We are going to see if there is a for loop, we are going on. For if statement, it will be on, o1. Then we are going to add all those time complexities and then we are going to take out final one. So this is the similar way we are going to work with in future. Now let's understand O log n time complexity. So let us understand this using an example of array. So here there is an array with elements 1 to 8. So if we want to find the element 8, what one we can do is we will be iterate from starting to ending. We will go through one by one element whether it is 8 or not. So it is 1, we will move ahead. It is 2, we will again move ahead. It is 3, we will again move ahead till it is 7, we will again move ahead, and then finally we will get 8. So after iterating through whole array, we will get the 8. But I don't think this is the sufficient way. So what we do is we will divide this array into two parts, 1, 2, 3, 4, and 5, 6, 7, 8. Okay, we divided it into half. So what we'll do is we will divide this array into two parts, first and second. As you can see in the first part, 8 is not there, so we will eliminate it, and then we will again further divide the second part in further two parts, that is 5, 6 and 7, 8. Again, is 8 over here? No. So we will again neglect this and we will again divide this array into two parts at 7 and 8, and finally we will get 8 over here. So as you can see, in this approach, we have divided the array into two parts in three steps. First step over here, second step over here, and third step over here. That is, let me show you. So value of n was 8 basically. So here n equals to 8 and number of steps, number of operations or steps of dividing required equals to 3. And as we know that 2 to the power 3 equals to 8. And taking log on both sides, we will get it as 3 log to the base to 2 equals to log to the base to 8. Log 2 to the base 2 will become 1, and finally we will get number of steps, that is 3 equals to log to the base to 8, which is our O log n time complexity where n equals to 8. So let us talk about space complexity. So basically in space complexity, whenever you have written a code, if it takes an extra space, an extra memory for execution, then its space complexity will be O(n), O(n), and if it doesn't need any extra space, if it doesn't create any extra space while executing, its space complexity will be O(1). So as you can see in this example, uh, a function add n is created. If n is less than or equal to 0, it will return 0 or return n plus some n minus 1. So here it is creating an extra space. So the space complexity for this function will be O(n). So this was for time complexity and space complexity. Now let us see an example of add versus multiply in time and space complexity basically. So let me create a function. Let me first remove this part and let me create a function called first, and I will pass parameter n over there, and for I in range and print I, and for j in range and print j. Now let me create first other function. Let us call it second. Sorry for the typo, and I will pass there n as well. Then for I in range n, for j in range n, print I comma j. So these are the two functions. So in the first function, the for loops are not nested. As you can see in the second function, for loops are written one below another, not one below another. You can say that this second for loop is under first for loop. These are nested loops basically. That is, this for loop condition will depend upon the first loop, and here it is independent of the first loop. That is, in second loop, for I in range n. So whenever this I will iterate, then only this second loop will iterate. Whenever you see two loops are nested, the nested loop, that is the second loop, will depend on iteration of the first loop. And here the j part is independent of this first loop because they are not nested. This for loop is not nested inside this, it is independent. So for independent loops, that is which are not nested, this for loop will have time complexity O(n). Okay. Let us neglect this print I time complexity, which will be O(n). That is non-dominant, constant, as we studied earlier. And the second loop will also have time complexity O(n), and the total time complexity for this function will be O(n plus n O)(2)n). Again, dominating the constant term, we will get final O(n). Let me make some space so that it looks clean. Okay. Now let's see the second function. So for this loop, time complexity will be O(n). Similarly for this loop, it will be O(n), but this time this for loop is nested inside this for loop. That is, time complexity total of this function will not be O(n), and it will be O(n) square. Let me edit this part, O(n) square. So I hope you have understand the difference between add and multiply of time complexities. So this was an important part, and we are definitely going to implement it in further lectures, calculating time complexities and also space complexities as well. So this was it for add versus multiply, that is independent loops and nested loops. So at last, rules to remember. See, remember these rules because these will be very helpful for you in future. Whenever you will code, these will help you to calculate the time complexity as well as space complexity for your code, and you can check whether your code is efficient or not, but sufficiently. So rule 1, whenever you see statements like assignment statements like x equals to 0, y equals to 1, or any assignment statement, or if statements, if x is greater than 2, if y is greater than 3, etc., then it's time complexity will be O1. Its time complexity means time complexity of that particular line of code will be O1, sorry. And then rule 2, one simple for loop that loops from 0 to n. So whenever you see any for loop, not nested loops, only single for loop, then time complexity for that loop will be O(n). Now coming to next rule, nested loops. Sorry, nested loops. For example, when you see two nested for loops, then it will be O(n) square. If three nested for loops, then it will be O(n) cube. But that will be considered as overall O(n) square. Then last rule, rule number 4, parameter of loop is divided by 2 at each step. Whenever you see that the parameter of the loop is divided by 2 at each step. For example, we have seen in an array of 8 members when I explained you O log n. Then we divided that array by 2 3 times, and then we get the desired value. So that was O log n. So whenever you see such approach in the code, remember that it is O log n time complexity. And the last and hard and fast rule is whenever you see multiple line of codes, just check these rules and write their particular complexities and then add them up or multiply them as I have taught you earlier. So this was all about time and space complexity. Now from next lecture onwards, we are going to start with arrays, linked list. We will see the code part as well as theoretical. We will understand them. Then we will implement different operations using code part on VS Code, and we will understand how to do it. So the main data structure and algorithm code part is going to start from next lecture onwards. We will start with arrays, following with linked list, and then the course will be continued. So if you have any query about this course till now, you can ask it in comment section. If you want any additional video about any topic, DSA or other than DSA like development or anything, you can ask me in comment section. I will definitely make a video on it. And if you have liked the series till now, show your love in comment section. If you think that something is missing in my series, that teaching is not of that level, or some content is missing, or something is wrong, or something error you have found out, so please let me know in comment section. That will be done correct. So stay tuned for the next lecture. Thank you so much.